right, good morning again. So let's look at these sample problems. I think this is on the third page of your reading. It's called electron dot structures for ionic compounds. So now we're going to show our Lewis dot structures in a compound and show how they form a bond, an ionic bond. So the sample problems here say draw the electron dot structures for the following ionic compounds. We have lithium bromide and calcium chloride. If we look at the periodic table, so let's focus on lithium bromide for a minute. We notice lithium is over here in the first group, and so this is actually going to form a +1 cation. So everything in this group will. Let's look at bromide. So bromine is over here. When it becomes an ion, we call it bromide. Next week, we're going to focus on naming compounds, so you'll understand that a little bit more. But everything over here, we know, just like we saw with fluorine, has a 1- charge. So we'll say -1. Okay, so these two ions, this cation and this anion, so we have bromine and lithium, they're going to be attracted to each other because they have opposite charges. So all we need to do is show their Lewis dot structures and then show them basically sitting next to each other and that they're attracted to each other. So that's how we kind of are going to represent that ionic bond. Okay, so let's go over the sample problem and then kind of try to understand what's happening. So let's focus on lithium bromide. So lithium, we know has one valence electron because it's in group 1. So we're going to predict it's going to lose that electron and become 1+ charge. Bromine is going to gain an electron. So it's going to gain this electron. It's going to steal it from lithium, and it's going to become 1- charge, 1-. Sure enough, here they showed it happening, right? So now we have Li plus and Br minus. And in the example problems here, they don't show brackets or, so we could put brackets here around this if we wanted to, just to show it's its own thing. And then we could put it over here next to lithium. So that's one way to do it. I just want you to be familiar with the different ways. Or erase. You could draw the circles around the two. So we could show lithium here and bromine. Now, sometimes when some of us draw these things, it gets a little bit messy. So that's why I like to draw the circles around it to say, okay, everything in this circle is for bromine. Sometimes it's hard to recognize, are these electrons on bromine or are they in lithium? When it's in a textbook like this and everything's perfect, it's easy to tell. But when we draw them, you guys know, right? Just like when I draw things, things get a little bit messy too. And so it's nice to have those options. Because, for example, this one for calcium, notice it has 2 anions here with lots of electrons. So that can get a little bit messy. Now, okay, we've focused on the lithium example. What about calcium? Calcium chloride. So calcium has 2 valence electrons that it needed to lose, but chlorine only needed to gain 1 electron. So if this were floating around in a solution, there's going to be lots of chlorines and lots of calciums. So 2 chlorines are actually going to steal an electron from calcium. So this chlorine is going to steal 1, but it doesn't need another one. Calcium still needs to get rid of 1 more. So there's going to be another chlorine over here with its valence electrons, right? And it's going to need another one. So the different chlorine is going to steal the other one. So when we come down here to our, well, let me erase this, to the final answer, you're going to notice that the final answer, calcium has a 2+ charge, and chlorine, there's 2 chlorines here that are now attached to calcium. So if I were doing this problem, this would be a nice one to draw circles around. So you could show that these are 3 separate particles and that they're touching